Yeah, hi. We are from SVS Embedded. The project title name is IoT based underground cable fault detection system using Raspberry Pi Pico and ESP8266 Wi-Fi module. So in this project, IoT based underground cable fault detection system based on Raspberry Pi Pico and ESP8266 Wi-Fi module. So here we are using ESP8266 Wi-Fi module. It requires mobile data, hotspot internet, username is project and password is project1234. So here we are using Raspberry Pi Pico RP2040 development board. So those are connected with RX, TX and 0 and 1. We are using 5 volts power supply board, 0 to 9 volts adapter power source, and it converts to 5 volts pure DC output. That 5 volts to given to the Arduino Raspberry Pi Pico development board. And we are using switch buttons RL1, RL2, RL3, YL1, YL2, YL3, GL1, GL2, GL3. Those are connected with the GPIO pin number of 10, 11, 12, 13, 14, 15, 16, 17, 18. So these are the input to the Raspberry Pi Pico. So we are taking the switch based cable fault detection. 16 cross 2 LCD display. Those are connected with RS enable D4, D5, D6, D7, 2, 3, 4, 5, 6, 7. And driver IC and one red LED. Whether red cable fault, red LED indicators, relay 1. Those are connected with the 19 pin. Yellow cable fault connected to the red LED 2 and driver IC GPIO pin number 20. Green LED fault, green cable fault, driver IC relay LED 3 and those are connected with the 21. So GPIO pin number 19, 20, 21 connected to the driver IC and relay 1, relay 2, relay 3, red LED 1, red LED 2, red LED 3. So this is our total block diagram of the project. And let us coming into the hardware. So here we are using 0 to 9 volts adapter power source. We are using 0 to 9 volts and 1 ampere adapter power source. And we are giving to the Raspberry power supply 5 volts power supply board. Okay. So bridge rectifier, filter capacitor, 7805 regulator and 1 LED, 5 volts power supply module. Raspberry Pi Pico RP2040 and this is the reset button. And ESP8266 Wi-Fi module, mobile hotspot internet and connected to the project. And here we are using one mobile phone. Then hotspot username is project and the password is project1234. And here the device will be shown. So whichever the device name is ESP module. Okay. So red cable okay, green cable okay, and orange cable okay, yellow or green cable okay. So it is connected to 16 cross 2 LCD display, character LCD display. Whatever the process is going on, that should be displayed on the LCD. And here we are using R1, R2, R3, Y1, Y2, Y3, G1, G2, G3. If everything should be okay, red cable, yellow cable and green cable. Okay. So now I'm going for the red cable second fault, green cable third fault, yellow cable one fault. Okay. So after every 5 counts of data, whatever the data, it is sending the data to server, then it will come back to the Raspberry Pi Pico board and it will give you one by one. Okay. Now it entered into the loop. Okay. So once loop will be executed, it will check for the total 10 counts. So 1, 2, 3, 4, 5. Once the counts will be completed, if anything you can operate. Okay. So 2, 3 like that. It is in the loop. Once loop will be completed, then it will go to the server. Then server will say, then it will goes to the ESP8266 and it will send the data to server. So R 2, 3 fault, yellow or orange cable 1 kilometer fault, green 3 kilometer fault. So that should be sending the data to server 2, 3, 1 kilometer and third kilometer. Then normal, come to normal. Okay. So okay, and all LED should be closed. Then go to Z2, R1, Z2, R1, only 2, G2, R1. Okay. So it shows the LED and after 20 counts of the data, then it will send the data to server using ESP8266 to this mobile internet and it will fetch the data to server. Okay. So R1 1 kilometer, G 2 kilometer. Okay. Once it is sending success, it will tell you, it will show you the data. We have to wait. Yeah. R1 G2. Okay. R1 G2. Okay, now normal, 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 normal. If all are okay, now it is in the loop. Once loop will be completed, okay, okay, okay. After every 20 counts of data, it will wait for 2 minutes of time, to 1 to 2 minutes of time. Then it will send the data to server. Okay, okay, okay. We have to wait. Once it is sending success. This is power supply board, 16 cross 2 LCD display, Raspberry Pi Pico board. So okay, all are okay, 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 okay. Then R1, R2, R3, Y1, Y2, Y3, G1, G2, G3. Then R1 fault relay LED indicator, Y1 fault relay indicator, G1 fault indicator. So now 3, 1, 2. Okay, so now it will update the data onto the server. Okay, once it is completed, this is our project block diagram, and it will update using this mobile data. Thank you.